So, yeah, I started this a little bit ago. This is my official solution. I don't know, is that me or you? Somebody drew on my screen. That's awesome. um, uh, anyone have any questions about this? Like, why did I do a certain thing? And then I'll just walk us through what I did. Cool. Well, so I said, I asked you guys to, say what we're going to do, and then get the first number, get the second number. And so it's important to do this int part, because that turns the input into a number. Otherwise, it would crash. And then I wanted you to keep track of how many prime numbers you found. That's what this line does. We start out with 0. And then this line, we're doing, coming up with, we're going to check all the numbers, and we're putting each number into this variable num. And we have to do this +1 here, because you remember the range call. You may not remember, range does 1 less than the second number. So, hey, by the way, Richard, who would come every Tuesday and help, he's been doing all of your assignments also from home. And I'm thinking next week I want to do another assignment where we say hello to Richard, and hello, thank you, and goodbye. We never got to say goodbye in the end to him. I mean, I'll see him next year, but you guys won't. So, so we'll do that. That'll be one of our things next week. Okay, so we're inside this for loop, and I'll even say, this is where we start checking each number. Okay, so then we say factors is 0. We're just going to count how many factors num has. Okay, so then for x in range 1, comma, num +1. So this will go, like, if the number we're checking is 17, this is going to go from 1 to 17. And then we're checking, hey, if num, the one we're checking, I'm going to rewrite this. Num is the number we are checking. That's really a better way to say this. All right, so we're checking num. Can num be divided evenly by x? And if it can, then we add 1 to how many factors we have. And then, so this whole thing, this is that for loop. It's just got 3 lines. This thing has to be after the for loop. This line has to be after the for loop. So see, it's outside of that for loop. And it says, hey, if we have 2 factors, then it's a prime number. So we better print it and then add 1 to our count variable. That's all. And then finally, this line is outside of all the for loops, and it gives us that little thing at the end. Okay, so now that I've talked about it, any questions? Did anybody do their, like, that thing I said where you figured out how long it took? I think I have my version of that. Well, I know I do. I'll show you guys my REPLs. I think it's this was the one I did last week before I assigned it. So I did import time up here. This was totally optional. And then I had a start time and then an end time, and then I printed out how long it took. So let's do one that doesn't take very long. The starting number is 1, the ending number is 2020. And well, that didn't take very long. Wow. Took a quarter of a second. I'll tell you something else I did on this version. I made it go twice as fast for really big numbers. For the interior loop, instead of going up to num +1, I went up to half of num +1. And that's because I was thinking about it, because I was doing really crazy runs with, like I showed you in my example, like this is 10,000. It takes a lot longer when you do, things in the thousands. And the trick is, when you're checking if a number is divisible by another number, once you get up to half of a number, you don't have to keep checking anymore. So the way I told you to do it, is wasting more time than it needs to. Because, like, if we're back to the number 17, once you get up to not 9, which is more than half of 17. Of course, 17 isn't going to be divisible by 10, 11, 12, 13. You know, anything bigger than half of a number is not going to divide evenly into a number. So that's why I changed this particular thing in the solution that I just showed you. It was just num plus 1, but this made it go faster. Cool. Any questions? Okay, somebody say something just so I feel like I'm talking to people.
Hip hip hooray.
Okay, thank you, Jack.
Hey.
That makes me happy. I guess, and I'm doing them out of order, sorry, but the LeetSpeak solution, we'll look at that. Thought I clicked on it. I had fun doing this assignment.
Yeah.
It was something that I always thought of us doing, and then, you know, I just didn't have time. So here's my solution. Again, I said what we're going to do. I asked the people to enter text. I made the text uppercase. So a common mistake here is people will do text equals text.upper without putting the parentheses on. And I think like it even tries to run, but it won't. We'll see. Yeah. I'm entering hamster and okay, well, it crashes then. But another thing people do is they'll just put on a line text.upper, but that in itself doesn't do anything. So you have to do as I showed you here. You have to say text equals. We're replacing what was in text with the uppercase version of text. And then I printed it just so I'd make sure it was actually working. And then made a variable called output and said it was empty. And then for X in text, this line gets you each letter one at a time. And so it's just checking, hey, if it's an A, replace it with that. If it's an E, replace it with that, and so on. Now, it's important that you put it all as a single if, elif, else. And I'll show you why, because if you just did this as an if over here, then what's going to happen is it'll do all the, you know, the A, E, T, S, B stuff. And then when it gets to K, if it's a K, it'll make it an X. And then otherwise, for every letter, it's going to add the output. It's going to add the original. I'll show you what, like, this is what I saw with somebody. Somebody emailed me. They were having trouble. So if I do a hamster, so see, it replaced the A with the 4, but then it threw the A on there anyway. And it replaced the S with the $, and then it threw the S on there anyway. Same with the T and the E. So that's why it's important that the whole thing be like one if, as many elifs as you need, and only one else in the whole thing. Somebody tell me something to type. Make sure it's school appropriate. We're going to translate.
Big dum dum.
All right, big dum dum.
Hell yeah.
Yeah, somebody else.
Wakanda.
It's a W, right, or an M?
W.
K?
Yeah.
On rules. Yeah, that changed it. The X. Yeah, I didn't know how many letters that would do. You know, that would be an interesting thing to add. How many letters got changed? How about this? Changed equals I'm going to say the number of characters changed equals the length of text. So I'm going to assume we changed every character. And then every time we didn't change a character, I'm going to say changed equals changed minus 1. Okay, so assuming we're changing every character, and then every time we don't change a character, I'm subtracting. And I'm going to say changed characters. Changed. I mean, just for fun. I'm thinking that would be an interesting statistic. Wakanda rules. Yeah, 5 characters changed. It's kind of a nice feature. Otherwise, you'd have to if you start changed at 0, you'd have to put in every single one of these things like changed equals change plus 1. So that's why I did the minus method. Hey, I'm going to stop sharing my screen. We're back here. I'm going to stop.